Hello friends, before starting our chapter Pairs of Straight Lines, let's quickly revise some concept related to lines. As we all know, line is basically a two-dimensional structure which is a combination of points. General equation of a line in Cartesian coordinate system, if this is a line and this is any point P, say x, y, then general equation is given by ax plus by plus c equal to 0. Now to find out the equation of lines under certain situation in this form, we have studied some results. Let's revise all those two. The first one is slope point form. In this form we used to have one point on required line and slope of the line is given. This is the slope of the line which is denoted by m, which is also equal to tan theta, and say this is any point p x1 comma y1. Then to find the equation of this required line, we used to use this relation. The another one which we have studied is 2-point form. In this we used to have 2 points on our required line. If suppose this is our required line and this is point P, say x1 comma y1, and this is point Q, say x2 comma y2. So to find the equation of this line, we use this result: x minus x1 upon x2 minus x1 is equal to y minus y1 upon y2 minus y1. Next one is double intercept form. In this form we used to have the x and y intercept of our required line. This is y intercept 0 comma b and this is x intercept a comma 0. Then we use this equation to find equation of this required line. One more which we have is slope intercept form. In this form we used to have slope of the line and the y-intercept of the line, which is 0 comma c, and this is the slope of the line. So we use this relation y equal to mx plus c to find the equation of required line. This here m is the slope and c is the y-intercept. Another form which we have is normal form. In this form, if this is our required line of which equation is to be finded, and this is the perpendicular distance of line from origin, say this distance is p, and this is the angle alpha made by the perpendicular line with x-axis in anti-clockwise direction. Then to find equation of this required line, we use x cos alpha plus y sine alpha equal to p, where p, as I said, is perpendicular distance of a line from origin, and alpha is angle made by perpendicular line with x-axis in anti-clockwise direction. We have studied one concept which is known as family of lines. In this we have studied if this is say line L1 and if this is say line L2 and this is line L3. Now if we are having the equation of line L1 and L2, then we can find the equation of line L3 by using this relation. This concept is known as family of lines. Next one is the important concept of line, that is how to find angle between two lines, two straight lines. Say this is line L1 and this is line L2 and this is angle theta between those two lines. Say line L1 makes angle theta 1 with x-axis and line L2 makes angle theta 2 with x-axis. Then to find out the angle theta, we have this result where M1 and M2 are the slopes of line L1 and L2 respectively. Here we should keep in mind that theta, the angle which we are getting between the line, is an acute angle between the line. There are two angles between the line. One is this theta and the another one is this one. This is the obtuse angle between these two lines. But what we get from this result is the acute angle between these two lines. So we should keep in mind that this is an acute angle between these two lines. And from this result we can conclude that if M1 is equal to M2, then lines are parallel, and if M1 into M2 is equal to -1, then lines are perpendicular. We can substitute this condition in this result to find out this required condition. These all things we have studied in our earlier classes. We have one more concept related to this line being parallel or being perpendicular, that is L1 and L2 are parallel if and only if A1 upon A2 is equal to B1 upon B2, where line L1 corresponds to A1x plus B1y plus C equal to 0, and line L2 corresponds to A2x plus B2y plus C equal to 0. One more we have is line L1 is perpendicular to line L2 if and only if this condition is satisfied.